Hello everyone. This video is on the Knewton Alta assignment for section 5.1 called Solving Systems of Linear Equations by Graphing. So in this video, I'm going to be doing a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, and the structure should be similar. So I'm hoping that watching me do these here helps you out in some way when you work on the assignment on your own. So on your assignment page, you should be seeing the title, the mastery bar telling you how far along you've gotten, the objectives. Looks like there are 4 objectives in this assignment. And under the current objective, there should be a question related to that objective. And at the bottom of every question, you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not have an instructor cheat button. Alright, this is for instructors only. But you will have a more instruction button, which if you're struggling with a topic or a question, try clicking on this and you'll be taken to a page with further reading or videos to study, and given questions related to that instruction, and working on those questions, completing those questions, will progress you through the assignment. Alright, so the first objective is solve a system of linear equations by graphing. Alright, now a system of linear equations is just multiple linear equations that are going to be graphed on the same coordinate system. There are multiple linear equations that are considered together, right? And for the most part, we are going to be seeing 2 equations with 2 variables. All right. For the most part. We'll come across other systems, I'm sure, but most of these will have 2 linear equation systems. Now, when they talk about solving a system, you're trying to find a point, an ordered pair, that satisfies every equation in the system at the same time. Now, if you're talking about linear equations in 2 variables, that's going to be, where do the lines intersect? What's this point of intersection? So I'm going to start off by showing you this system here. So the system we're given, we have 2 linear equations. Y equals negative 4x minus 9, and the other one is 2x plus 2y equals 6. So first I'll make a graph of the system. Now if you have graph paper, that would be even better. But I'm just going to try my best to make this look decent and keep everything nice evenly spaced. So I'm going to graph this first line in one color, and I'm going to graph all the solutions of the second line in another color. And then they're asking us for a solution of the system. Right, a solution of the system, as I said out loud a second ago, this is any ordered pair that satisfies all the equations in the system, not just one of them. So in this case, both equations. There's only 2 of them. Right? So it's an ordered pair that satisfies all the equations in the system at the same time. So I'll graph again. The first one, y equals negative 4x minus 9. Now that would have a y-intercept of negative 9. 2, 3, 4, 5, 6, 7, 8, 9. There's negative 9. and the point 0, -9, and it has a slope of -4. So I could go down 4, right 1, or up 4. 1, 2, 3, 4, and then left 1. So the point -1, -5 should also be on the graph of that line. Alright, and I'll do this in like an orangish color, or whatever color you're seeing. So there's one line. I'll label it with the equation as well. There's the graph of y equals -4x minus 9. Right? Now the other line, I'm going to graph it again a different color. 2x plus 2y equals 6. Now I can put that in slope-intercept form if I want. Or, it's pretty easy to graph the intercepts here. 3, 0, right? 3 for x, 0 for y. That's the x-intercept. And 0, 3 is the y-intercept. So this has a slope of -1. This has a slope of -4. So they're going to cross somewhere. Again, my graph is a hand drawing. It's not the greatest. I'll put this in like a light green color. And yeah, this isn't the best, but so here's the graph of that line. Now you see they're going to cross eventually. Let me actually make this a little longer. They're going to cross at some point way out here. All right. It's in my in the middle of the system here. Here's where the solution of the system's going to be. All right. It's the ordered pair that satisfies both of them, right? That's on both lines. Now, this is it's a hand drawing on paper that's not graph paper. So it's pretty hard to tell what that ordered pair is. It would be a lot, like I said, if you have graph paper and you want to do these by hand, that would make it a lot easier. Or we could actually just get some assistance here. I'm going to go to the desmos.com, right, free online graphing calculator, and I'll graph these lines. Right, y equals -4x minus 9, because you see how it has like a grid paper. It's a nice grid. And then the other one was 2x plus 2y equals 6. And you see how they are crossing way out here. And that looks like, -4 on the x and +7 on the y. Now you can just easily click. Now the nice thing about Desmos, you click on one of these, it'll show you where they cross, and you can label it. That's the point -4, 7. So yeah, my hand drawing was, they meet in quadrant 2. Sure, they meet in quadrant 2, but man, this is actually pretty terrible. That should be the point -4, 7. All right, -4, 7. But that's what we're doing. We're graphing these lines, and once again, if you have graph paper, even better, and trying to figure out, where do they cross, if they cross. All right, there will be some situations where we have parallel lines that never touch, so there'll be no solution. Or we'll have two lines that are exactly the same, so they'll have, infinitely many solutions. We'll talk about that in another objective. Now back in the assignment, right, you're just plotting these graphs, right? See, I don't think they have any particular, they don't tell you to make one red or one blue. There's a red line and a blue line, and then a green point where they intersect. So I'll just graph the lines. The one had 0, -9. Right, 0, -9 was the y-intercept, and had -1, -5. All right, there. So there's the first line, y equals -4x minus 9. Then the other one had 3, 0 as the x-intercept, and 0, 3 as the y-intercept. And there you go. And then for the point of intersection, all right, we're moving this to the point where they cross, and make sure it's at, at the point where they intersect. And that's all we're asked to do, right? Graph the two lines, move the point to the point where they cross, which is at negative 4, 7 looks like, and then submit. Now once you submit an answer, it'll tell you if you're correct or incorrect, and then give you some sort of answer explanation. Please read through the answer explanations just to make sure you understand why something's correct or incorrect, and hopefully you can learn from your mistakes for future questions. Alright, oh, and one more thing I wanted to point out was, that point negative 4, 7, this satisfies both equations, right? If I plug in negative 4 for x and 7 for y, the first equation you'd have 7 equals negative 4 times negative 4 minus 9, right? That's 16 minus 9 equals 7, that's true. And then the other equation, you'd have 2 times negative 4 plus 2 times 7 equals 6. This is negative 8 plus 14 equals 6. That's true. 6 equals 6. So you see how that ordered pair does indeed satisfy all the equations in the system. So it would therefore be called a solution of the system. The only solution, right? That is the only point that satisfies both. Alright, so moving on. Yeah, so now we're back to just plugging in and checking. Alright, all we have to do here is plug and check. It says determine whether an ordered pair is a solution of a system of linear equations. So here we're given a system of two linear equations, and we're just asked, which of the following ordered pairs, and there's only one correct answer. It says select the correct answer. Which of the following pairs satisfies both of these? Alright, so I'm going to do this one the long way, and then after this example, again, you can just go to Desmos and make the graphs and see where they cross, if they cross at all. Alright, so I'll write this out. And if you want to, we could make little graphs. Make some graphs by hand, even though my graphing by hand isn't going to be great because I don't have graph paper. But the system we're given, 10x minus 6y equals 9, and then negative x minus 2y equals 3. Right. So I can get a rough idea. Again, this isn't going to be great, but I'm going to get a rough idea where the solution is just by making a quick graph. The first equation, if x were 0, y would have to be negative 9, 6, which would be negative 3 halves or negative 1.5. So let's say this is negative 1, negative 2. There's the y-intercept at negative 1.5. And if y were 0, x would have to be 9/10. So, here's again, I'm trying my best. 9/10, really close to 1. Something like that. Alright. So here's this first line. Maybe I should make them thinner. Alright, but here's this first line. Alright, something like this. It's got a positive slope. Alright, then the other line, if x were 0. Oh wow, okay, well, that settles it, doesn't it? If x were 0, y would be negative 3 halves, which is the same y-intercept as the other line. So that's got to be the solution then. Alright. And then if y were 0, x would be negative 3. So negative 1, 2, 3. Negative 3, 0 is the x-intercept for that graph. And if I plot the graph of these, that second line here, we get this line. But again, I hope it's obvious what the solution is. Right? The solution is this point right here, 0, negative 3 halves. that's the point of intersection. It's the solution. So all the other ordered pairs they gave you won't work. Right back here, if you plug in -2 for x and -29.6 for y, it'll make the first equation work, but not the second one. Like this ordered pair, the first one, it satisfies the first equation, but not the second one. This equation here, 8 2/5 times 10 would be 4, and then plus 6 would be 10. This doesn't satisfy the first equation. And 30 plus 18, this doesn't satisfy the first equation. All these other ordered pairs, except for this one, 0, -3 halves works for both of them, but all these other ordered pairs either fail to satisfy one of them or both of them. Right? A solution of a system has to satisfy all the equations in the system. So 0, -3 halves is the solution there. So yeah, if you want to make a graph, you saw from my graph there, that made it a lot easier to determine which of those ordered pairs was working. Right, and they go through and show you the check for all of them. Right? And again, read through the answer explanations. Alright, so here's solve applications of systems of linear equations by graphing. So here we have to write our own equations, and I think that's just part 1 of this, and then we have to find the solution maybe, I don't know. We'll see what happens. So remember how you work with an application problem or a word problem, right? You read through the problem, then you what's unknown, what do they want, right? Call those something, name them, and then using keywords, going back through the problem, you should be able to translate into math, into equations or inequalities or whatever. So here it says, Owen is making lemonade from concentrate. The number of quarts of water he needs is 4 times the number of quarts of concentrate, and he wants to make 100 quarts of lemonade. So let C represent the number of quarts of concentrate. They're giving you the names, so that's step 2. They're giving us the letters. So let C represent the number of quarts of concentrate, and W represent the number of quarts of water Owen will use. Which of the following systems of equations models this situation? Well, right away we see, going back and reading it again, the number of quarts of water, that was W, equals 4 times the number of quarts of concentrate. So we should have W equals 4C, which I'm seeing here and here. Right, so it's one of these two options, W equals 4C. But then the other equation comes from the next sentence. He wants to make 100 quarts of lemonade. So that means if you put the quarts of concentrate with the quarts of water together, it should make 100 quarts. So W plus C equals 100. I hope that makes sense. So quarts of water is 4 times quarts of concentrate, W equals 4C. And the total number of quarts together, he's making a total of 100 quarts of lemonade. W plus C equals 100. That's this equation, or this system of equations here. Alright, so yeah, it's just like any other word problem. You read, you assign letters to things, you then go and use those letters to set up equations based on some keywords. Okay, and then I don't know if they're going to have us try solving this now. Yeah, so I think that's the next question. Now they actually have us trying to solve how many quarts of concentrate, how many quarts of water are necessary. Now you could have probably already guessed that it's 80 and 20. 80 quarts of water, 20 quarts of concentrate. But let's look at a graph. All right. Now on paper, the system we had was, number of quarts of water equals, 4 times the number of quarts of concentrate, and the number of quarts of water plus the number of quarts of concentrate was 100. Now, if you were graphing, now, you can call one of these x and one of these y. Instead of x, I'll use C for the concentrate, and instead of y, I'll use W. And the first equation, is in W equals 4C plus 0. This would have 0, 0. And then, if I plug in 1 for C, I'd get 4 for W. All right, 1, 4. And there's this graph, right? All right, there's the graph of the first equation. And the second equation, you'd have that's why I'm going to go to the Desmos site here. But if C was 100, W would be 0, and if W was 100, C would be 0. Those are your intercepts, and there's this line here. All right. Again, this is a terrible hand drawing, but there's the other line, and they definitely cross somewhere. All right, they definitely intersect somewhere, and that's going to be the solution of the system. All right. Now, like I mentioned, this is going to be, C is 20, and W is 80. Right? Because 4 times 20 is 80, and then 20 plus 80 is 100. I'm telling you right now, that's the solution. C is 20, W is 80. We're going to figure out in future videos, right, after this section, we'll talk about how to solve this without a graph. I kind of just did that in my mind. All right, but I'll show you how to do this in a future video. But for right now, we're graphing. So, if I go back to the Desmos site, now I don't think it'll do W's and C's. I think you have to change it to Y's and X's. W equals 4C. Ah, it does. All right, and W plus C equals 100. You can't put more than one equation with it because it doesn't understand, but Y's and X's it will. All right, so I'll do that instead. Y equals 4X. So instead of W, I'll call it Y, and instead of C, I call it X. And then, Y plus X equals 100. It'll graph those, and then you can kind of zoom out and see if they cross anywhere. I'll look at this, right, and then click on one of them. You can see where they cross, 2080. All right, 2080. Like I said. All right, then back in the assignment, 20 quarts of concentrate, 80 quarts of water, and that's the solution. See, again, we're only using graphs in this particular section, this particular assignment. We will see other methods of solving these systems in a later video. Alright, so back to solving a system by graphing. Alright, so once again, I'll draw this one out by hand. I'll go to the Desmos site, and then we'll come back here and make it here. So the system I'm given here, first equation, y equals 2x plus 1. Second equation, negative 3x plus 3y equals 12. Again, pretty simple to graph. Now, once again, I'm doing a hand drawing without graph paper, so this might not be the greatest thing in the world. But 0, 1 would be the y-intercept of the first equation, and then it has a slope of 2. So 1, 3 should be on the graph of that as well. And I'm just going to draw that in as best I can. Alright, so something like this. There's that graph, and then the other graph, the other equation has if x were 0, y would be 4. There's the y-intercept, and if y were 0, x would have to be -4. So again, this isn't the greatest. And this would have a slope of 1. This has a slope of 2, so they're going to meet. You know, any lines with different slopes are going to meet somewhere. Right, the only lines that won't meet are lines with the same slopes, right, and different y-intercepts. So they're going to meet somewhere out here in quadrant 1. Again, I can't really, based on the drawing anyway, I can't. I mean, maybe that's at like 4 or 9 or something, but it's not. All right. Yeah. So let me go to the Desmo site. Like I said, we'll talk about a more algebraic way of solving these, finding the exact point where they cross in another video. For right now, we're just graphing. So y equals 2x plus 1. And -3x plus 3y equals 12. Alright, so you see where they cross. They have it right here. It's at 3, 7. Alright, so on my drawing here, again, looks terrible because this should be at 3. I mean, based on that does not look like 3 based on my drawing, and same thing here. This should be at 7. Pardon me. But it does, my drawing's terrible. All right, I don't because I don't have graph paper. I would recommend getting graph paper if you're going to do this by hand. And you can double check when x is 3 and y is 7. Both of these are true. All right, and I'll leave that to you to check. Yeah, so that's what we're doing in the assignment is moving move these 2 red points to graph the first line. So one was at 0, 1. And 1, 3. 1, 2, 1, 3. There's the first line I graphed, and then the other one had 0, 4. Let's put the label up so I can see the coordinates. And then the other one had the other point was -4, 0. Maybe get rid of that label there. Okay. -4, 0. There's the second line, and then the point of intersection. You can see it's highlighted in gray when you click on one of the graphs, and you can move that point to and make sure it's on it. Yeah, it looks like it's at the point of intersection. That should be the point 3, 7. Wonderful. All right. Great. All right, next. All right, now this one's about, determine the number of solutions of a linear system. With all of these 2-line systems, 2 linear equation systems, you've seen so far all the examples we've been looking at have had one solution, right? Exactly one point where they cross each other. But you could also have no solution if the 2 lines are parallel, or infinitely many solutions if they're the same line. All right, so I'll write out each of those cases. All right. So systems of 2 linear equations with 2 variables. Systems of 2 linear equations with 2 variables. You have one of the following 3 scenarios. 1, the 2 lines have different slopes. All right, they're going to cross each other at one point. Exactly one solution, one point of intersection. Like I said, the lines have different slopes in this case. Any 2 lines with different slopes are going to cross somewhere. The second scenario is they're parallel. Alright, you draw one, you draw the other, and they run in the same direction, but they're not the same line, right? So they have the same slopes, but different y-intercepts. They're parallel. But different intercepts. Alright, they're parallel lines. In this case, there's no solution to the system. Right? They're never going to cross. There's no point that satisfies both equations. And the third case is, you draw one line, and then you go to draw the other line, and it's exactly the same thing. The lines coincide. The lines coincide. Or they are the same line. Right? They're the same line. They're right on top of each other. In that case, every single point on the line is a solution. Right? Every point on the line is on both lines. So every point on the line is a solution, meaning that this kind of a system would have infinitely many solutions. Alright, so that means they have the same slopes, the same intercepts, they're the same line. Alright, so the example we're given first, this first question in this objective, is this system. The first equation, negative 8x plus 7y equals negative 7. Second equation, 7x plus 4y equals 8. And I think it's really easy to tell what scenario you're in. Will you have one solution, no solution, or infinitely many solutions? I think it's really easy to tell that if you put things into slope-intercept form. Y equals mx plus b. So this first equation, I would add 8x and then divide everything by 7. Y equals 8/7 times x minus 1. So that first equation, the line has a slope of 8/7 and a y-intercept of -1, 0, -1. Then the second equation, where I would subtract 7 divided by 4, you'd have -7/4 x plus 2. So these have different slopes. Alright, these have different slopes. Alright, and if they have different slopes, they're going to cross at one point. They're going to have one point of intersection. There's going to be exactly one solution to this system. Alright. So one solution to that system. Now what the solution is, they're not asking. They're just asking how many. Alright. Great. Alright, and then another one like this. So again, I'll write this system up. We'll ask, how many solutions will the system have? So the first equation, 4x minus y equals -9. Second equation, 28x minus 7y equals -63. And you see, if I put both of these into slope-intercept form, the first one would be y equals 4x plus 9. I'll just add 9, add y. Second equation, subtract 28x, divide everything by -7, it'd be 4x plus 9. These are the same line. So that was that third case where there are infinitely many solutions. Every single point that's on the first line is also on the second line because they're the same line. So every single ordered pair that's a solution of the first equation is also a solution of the second equation, and therefore a solution of the system, right? So this has infinitely many solutions. Right. And that's what they're asking here. Oh, Okay, so some definitions. So back to that page. Sorry if it didn't cross my mind here. So some definitions here. Put this off to the side. So one, a system that has solutions is called consistent. So a system with solutions, one solution, infinitely many solutions, is called a consistent system. Two, separate these. A system with no solution is called inconsistent. Right. And then the words you saw on the problem just now, this number 3, a system with a finite number of solutions. Finite, not infinite. Right? So just one solution, like this here. Right? So this is the system with just one solution. This is called an independent system, or is just independent. Has an independent set of equations, they would say. And lastly, a system with infinitely many solutions a system with infinitely many solutions is a they say the equations are dependent. One depends on the other. They're the same equation in this case with the two equations and two variables. This is dependent. Alright, so once again, recap. If it has any solutions at all, they'll use the word consistent maybe once in a while. If it has no solutions, it's inconsistent. And then if it has solutions, right, if it's consistent, then you got one of these two cases. If it's consistent and the number of solutions is finite, like there's only one of them, that's an independent system. And if they have infinitely many solutions, then it's a dependent system, right? So this example had infinitely many, so dependent system. Right. I guess you could also say 0 is finite. They're including 0 in there too, it looks like in this text. So no solution, also an independent system, because that is a finite number of solutions, 0 solutions, right? You can count them. So yeah, I've seen other texts where that's not the case. I just forgot that it was the case in this one. Sorry. All right. Next. All right, so back to determining whether an ordered pair is a solution of a system or not. So once again, you can go through and plug each of these in to see which one satisfies all the both the equations here. I'm just gonna graph these and see where they meet back on Desmos. So one equation was negative 6x minus 6y equals 4. And the other equation y equals x minus 3. And zoom in back to home, and they meet at the point this. Alright, which is actually 1 1/6 rounded to 3 decimal places and negative 1 5/6. So that's this here. Negative, 7/6 is 1 1/6 or 1.166666. Negative 11/6 is negative 1 5/6 or negative 1.833333 forever. Now again, you could have just also plugged these values in for x and y and seen that it does satisfy the first equation and the second equation, and that would have eventually, you would have also eventually seen that the other four don't work for some of these. Maybe they'll satisfy one equation but not the other. I'll leave the handwork to you though. This is just a lot of busy work. And again, see through the answer explanations how they're checking every single one. Alright, so another one we're asked to solve by graphing. Alright, so this one I'll just going to move the points around. Alright. So the first equation would have a y-intercept of 0, 9. Oh, so I see that they're actually telling you the red one needs to be y equals 7/2 x plus 9, and the blue one needs to be negative 2x plus y equals 6. Alright, so 0, 9, y-intercept, and the slope is 7/2. So I can go up 7, right 2, or down 7, left 2. So from 0, if I go down 7, I'll be at 0, 2, and then left 2, I'll be at negative 2, 2. Yeah, so negative 2, 2 should be on this. Right. Okay, so there's the graph of the first equation. Then negative 2x plus y equals 6 would have 0, 6 as the y-intercept. There's 0, 6, and then negative 3, 0 as the x-intercept. Alright. Oop, that's negative 2.5. Negative 3, 0 is the x-intercept. And it looks like they meet at negative 2, 2. And let's see, I mean, if you were negative 2, 2 definitely satisfies the first equation, and x negative 2, y 2 would make 6 equals 6 satisfies the second one. Right. So I graphed both lines and saw, hey, the solution is where they meet. That's at the point negative 2, 2. Great. All right. Next. All right, so another one where we have to move points around on a graph. All right, now this one doesn't tell us, whether red needs to be what or blue needs to be what. So I'm just going to do the same thing where I do red is the first equation, blue is the second one. So this has a, y equals negative 7/2 x plus 9. That would have a y-intercept of 0, 9. So 0, 9. A slope of negative 7/2. So I go down 7, right 2. That's 2, 2. That's right there. That's perfect. And then the other equation, 2x minus y equals 2, you'd have 0, negative 2 for the y-intercept. There's that. And then 1, 0 for the x-intercept. There we go. And it looks like they meet at 2, 2. And they would. Yeah, 2, 2 satisfies both equations, and you can check that out. Plug in 2 for x, 2 for y, both equations should be satisfied. Great. Alright, so there, those shouldn't be so bad if you know how to find points on a graph, and you should by now, right? Points on the graph of a line. And then see where they meet. Right, that'll be the solution of the system. Alright. Alright, so now we're back to this checking, once again, you can spend. Ooh, Oh, okay, no, these will have different slopes, so there's only going to be one solution. I was about to say, see it says select all that apply, meaning that there might be more than one, but these two lines have different slopes. If you were to add 2x, the first line has a slope of 2, And the second line is in slope-intercept form, has a slope of 2/5. So these are going to have, this is going to have one solution. Now let's go to the calculator. All right, you can check all the points by hand if you want, but I don't know, just for the purposes of this video and speed, I don't really feel like doing that. So negative 2x plus y equals 8, and y equals 2/5 x minus 8. 2/5 times x minus 8, and they definitely cross, right? They have different slopes, and they cross over here. Looks like that's it. Negative 10 for x, negative 12 for y. So only this one. I know they're trying to trip you up here, saying select all that apply. Now, if these two lines had the same slope and the same y-intercept, if they were the same line, then there may be more than one solution, and you'd have to go in and actually check. Or plot the points on Desmos and see if the points actually show up on the line. Right? But the only one that works here is negative 10, negative 12. Okay. All right, then same thing here. Now they're just asking for 1 point. Does this ordered pair satisfy this system? Alright, so you know what? Because it's only 1 point, I'll actually write this one out. Right. Now you could graph this and see if that point's the one where they meet, or if it's actually on both of them, if they're the same line. But let's just see. Alright, so the system we're given, negative 8x minus 10y equals 3. And the second equation, 6x minus 6y equals 9. Alright, and then the point that we're checking, is this a solution? Is this the point of intersection? 2/3 for x, negative 5, 6 for y. So I plugged that into both of them. Now I'll call this equation 1 and equation 2. Alright, so in equation 1, we have negative 8 times 2/3 minus 10 times negative 5/6. Is this equal to 3? Well, this would be negative 16/3. And then, 2 goes into 10 5 times and into 6 3 times. So this becomes positive 25/3 equals 3. And this is indeed 9/3. 9 divided by 3 equals 3. 3 equals 3. Absolutely, that works. But just because it satisfies the first equation doesn't mean it's a solution of the system. Right? It could just be a point on that line, but not on the other line. So now I got to check equation 2. 6 times 2/3 minus 6 times negative 5/6. Is this equal to 9? Well, let's see. This is 4, and then this is plus 5 equals 9 totally. 9 equals 9. So yes, this is a solution of the system. It satisfies both equations, all the equations. Great. All right. Then how many solutions will this have? Well, these are actually the same equation. Can you see how if I took the first equation and just multiply both sides by 2, it would be the second equation? So yeah, you can put both of them in slope-intercept form, but they are the same equation. They're the same line. They're right on top of each other. So every point on this line is a point on that one. Every point on this line is a solution of the system. Every point on this line is a solution of the system. There's infinitely many solutions to this one. That one was pretty easy to see. Alright. Same thing here. How many solutions will this have? So if I were to put the first one in slope-intercept form, I'd add 9x and then divide by 5. So it would have a slope of 9/5. And it would have a y-intercept of 2. Alright, 10 divided by 5. So this first one has a slope of 9/5 and a y-intercept of 2. Here I'd subtract 36/5, multiply everything by negative 1/4, or divide by negative 4. that would also have positive 9/5 as a slope, but have -1 as a y-intercept. So these have the same slope but different y-intercepts. So these are parallel. These are not going to cross. These have no. This system has no solution. So this would be an independent system, right? Those ones with no solution or one solution are independent, and infinitely many are dependent. All right, and again, you see them here putting slope-intercept form and all that. All right, then back to the applications. So again, read through it and translate into math here. Eli is making a party mix that contains pretzels and Chex. This is basically like the lemonade with water and concentrate from earlier. For each cup of pretzels, he uses 3 cups of Chex. So basically, the number of Chex cups is 3 times the number of pretzel cups. Right? Because 1 cup of pretzels would be 3 cups of Chex, right? Or if you take the number of Chex cups, divide by 3, you get the number of pretzel cups. So C divided by 3 equals P. So it's either the first or the fourth one. And then he wants to make 12 cups of party mix, so the number of P plus C would be equal to 12. So it's got to be this first one here, where the Chex cups divided by 3 is equal to pretzel cups, and then pretzel cups plus Chex cups equals 12. Alright, and then probably, again, you'll probably have to solve the system now. Alright, how many of each kind of thing would he need to use? 9 and 3. So again, if you want to graph these, say P is Y and C is X. Y equals X divided by 3, and then Y plus X equals 12. Let me graph that here. So Y equals X divided by 3, and then Y plus X equals 12. And you see they meet at 9, 3. X is 9, Y is 3. And remember, X was the number of Chex, Y was the number of pretzels. So 9 Chex, 3 pretzels cups. Right. So 3 pretzel cups, 9 Chex cups. The end. All right. Great. And like I said, we're going to find, I think, easier ways of solving these without a graph. Yeah. And that should be it for the, and we'll do that in a future video. And that should be it for this preview version of this assignment. And like I said at the top of the video, right, the questions here may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same. The structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment yourself. And thank you very much for watching.